In the early 19th century, electricity was one of the most mysterious forces known to science. Researchers could create sparks, shocks, and glowing wires, but they did not truly understand how electricity behaved. Experiments produced fascinating results, yet there was no clear rule that explained why electricity moved the way it did. Scientists across Europe were exploring this strange invisible force, hoping to unlock its secrets. But despite their efforts, electricity still seemed unpredictable and chaotic. Then a quiet physicist made a discovery that would transform electricity from a mysterious phenomenon into a predictable science. His name was George Ohm. To understand why Ohm's discovery was so important, we need to step back into the early 1800s. Electricity had fascinated people for centuries. Ancient civilizations knew that rubbing amber could attract small objects, but the true scientific study of electricity only began much later. By the late 18th century, scientists had begun experimenting with electrical charges, sparks, and static electricity. However, they still lacked a reliable way to produce continuous electric current. That changed in the year 1800. An Italian physicist named Alessandro Volta invented the world's first battery, known as the voltaic pile. For the first time in human history, scientists could generate a steady flow of electricity. This invention sparked a revolution in electrical experiments. Across Europe, laboratories filled with wires, metal plates, and batteries as scientists rushed to explore the possibilities of this new energy. But there was a problem. Even though electricity could now be produced, no one truly understood the rules that governed it. Sometimes electricity flowed easily through a wire, sometimes it barely moved at all. Different metals produced different results. Longer wires behaved differently from shorter ones. The behavior of electricity seemed confusing and undetectable. What scientists needed was a law, a mathematical relationship that explained how electricity worked. And this is exactly what George Simon Ohm set out to discover. Unlike many famous scientists of this time, Ohm did not work in prestigious research laboratory. He was born in Germany in 1789 and spent much of his early career working as a school teacher. His father had encouraged his education, teaching him mathematics and science at home. This early training sparked Ohm's curiosity about the physical world. However, his professional life was not easy. He did not have access to expensive equipment or major scientific institutions. Instead, he conducted his research using relatively simple tools. In a modest laboratory environment, Ohm began experimenting with electrical circuits. He connected batteries to wires made from different materials and carefully measured the results. What he was searching for was a pattern, a consistent rule that explained how electrical current behaved. Ohm approached electricity in a way that many scientists before him had not. Rather than performing dramatic demonstrations, he focused on careful measurement. He experimented with wires of different lengths and thicknesses. He used different materials such as copper and other metals. Each time he connected the wire to a battery and measured how much electric current flowed through the circuit. Again and again he repeated the experiments. Slowly he began to notice something remarkable. The current flowing through a wire depended on two key factors. The first factor was the voltage provided by the battery. Voltage can be thought of as electrical pressure, the force that pushes electric charges through a circuit. The second factor was something that resisted the flow of electricity. Some materials allowed electricity to pass through easily, while others made it harder for the current to move. Ohm called this opposition resistance. As he analyzed his measurements, Ohm realized that these quantities were connected in a very simple relationship. The electrical current flowing through a conductor was directly proportional to the voltage applied across it. At the same time, the current was inversely related to the resistance of the conductor. He expressed this relationship using a mathematical equation. Voltage equals current multiplied by resistance. Or more simply, V equals I times R. This equation became known as Ohm's law. At first glance, Ohm's law appears extremely simple, yet its implications were revolutionary. For the first time in history, scientists could predict exactly how electricity would behave inside a circuit. If the voltage increased, the current would increase. If the resistance increased, the current would decrease. This relationship made it possible to design electrical systems with precision. Electricity was no longer a mysterious force producing unpredictable results. It had become a phenomenon that could be measured, calculated, and controlled. But despite the importance of his discovery, Ohm did not receive immediate recognition. When Ohm published his research in 1827, many scientists were skeptical. Some critics argued that his mathematical approach was too theoretical. Others believed that electricity was far too complex to be explained by such a simple equation. The reaction was harsh. Some academic institutions even dismissed his work entirely. The criticism affected Ohm deeply. His career suffered, and for several years, his discovery remained largely ignored. It is one of the great ironies of scientific history that a principle now taught in classrooms around the world was once rejected by many of the leading scientists of the time. Over time, however, the truth of Ohm's discovery became impossible to ignore. As electrical research progressed, more experiments confirmed the relationship he had discovered. Engineers and scientists found that Ohm's law accurately described the behavior of electrical circuits. Gradually, the scientific community began to acknowledge the significance of his work. By the mid 19th century, Ohm's law had become a fundamental principle of electrical science. Eventually, the international scientific community honored his contribution by naming the unit of electrical resistance after him. Today, resistance is measured in ohms, represented by the Greek letter omega. Ohm's discovery did far more than explain a scientific curiosity. It laid the foundation for an entirely new field, electrical engineering. With Ohm's law, engineers could calculate how electricity would behave in complex circuits. They could design electrical systems with accuracy and reliability. This knowledge made possible many of the technologies that define the modern world. Electric lighting systems rely on precise control of current. Power plants distribute electricity across vast networks of transmission lines. Electronic devices operate using carefully designed circuits. All of these systems depend on the simple relationship discovered by Ohm. Today, it is almost impossible to imagine a world without electricity. Homes are illuminated by electric lights. Cities are powered by vast electrical grids. Computers, smartphones, satellites, and the internet all rely on complex electronic circuits. Every one of these technologies is built on principles that include Ohm's law. When engineers design a circuit board for a computer, they must calculate how current will move through thousands of tiny pathways. When power companies design electrical networks, they must ensure that voltage and resistance are balanced across long transmission lines. Without the ability to predict electrical behavior, these systems simply could not exist. In this way, Ohm's discovery helped pave the way for the electrical age. The story of Georg Ohm reminds us that scientific progress does not always come from famous laboratories or well-funded institutions. Sometimes it begins with a curious mind, simple tools, and a determination to understand the world. Ohm was not a celebrity scientist during his lifetime, yet his work fundamentally changed humanity's relationship with electricity. What started as careful measurements of wires and batteries eventually became one of the most important laws in physics. Today, students across the world learn Ohm's law as one of the first principles of electricity. The equation appears simple, but its impact is enormous. It transformed electricity from an unpredictable force into a field governed by clear mathematical rules. That transformation allowed engineers and scientists to harness electricity in ways that early experiments could never have imagined. From lighting homes to powering global communication networks, electricity now shapes nearly every aspect of modern life. And it all traces back to a discovery made by a determined teacher experimenting with wires nearly 2 centuries ago. The story of Ohm's law is more than a scientific discovery. It is a reminder of how human curiosity pushes the boundaries of knowledge. Each breakthrough builds upon the work of those who came before, expanding humanity's understanding of the universe. The journey of discovery continues today as scientists explore new frontiers in energy, technology, and physics. And every new discovery adds another chapter to the story of human knowledge. If you enjoy exploring the discoveries that shaped our world, subscribe to Frontiers of Human Knowledge for more stories from the frontiers of science and human progress.